Ladies and gentlemen, welcome back to the workshop. It is fantastic to have you here as ever. Now, this is going to be an interesting little episode, an episode of trials, tribulations, travels, and successes. So stay tuned, because you remember recently did my first chips on the lathe? Well, we're going to circle back to about 2 hours after I finished filming that video right about now. So I just get done filming my first chips on the lathe video, walk around the back of the machine, and would you look at this? It's leaking. That is all the oil that I poured into it just a few moments ago on the floor. I think it's not dripping down the outside of the machine, but it's kind of coming out from the bottom. So I think I need to get into the back. Oh, thank you, Will. There goes the top cover. There comes the bottom. This to me screams the end of an oil pipe. That's worrying, because there's this here. That's definitely the end of an oil pipe. This is probably a good idea. Unplug it. Think you found it?
Yeah, so it's running off of that down, and it's actually dripping off of the electrical box.
Oh, lovely.
On this side.
Thank goodness. Dripping off the electrical box. Isn't that just a great thing to hear?
Yes.
Okay.
I think we can probably tighten these fittings up in here.
Yeah, then maybe that will fix it. Yep, the oil is definitely dripping off the electrical box. Well spotted, Will. So it looks like the oil is following down this little piece of conduit. Maybe it's tightening this. That'll be the trick. So this isn't good. We thought it was just running down that pipe through capillary action, but there is an obscene amount of oil in there. This is horrifyingly... This is not good. And I think what's happening is it is coming down through the conduit. Literally flowing through the pipe. That's not good.
No. How does it get in there?
I wonder if maybe the oil's leaking into this, because we know there's some electrical stuff in here, then maybe that's then flowing down there. Oh! That was easy! That is super satisfying. Oh! Would you look at that?
Oh, lovely.
Beautiful little puddle. And look, that's exactly what's happening. The oil is inside of the electrical conduit. Wow. Lots and lots of oil. We think there must be a leak at the bottom of whatever kind of holds the oil at this level, because similarly there is oil underneath there. This is not very good. The investigation continues. When you oil it from the top, you oil through this hole, and it goes straight down into all of this. Firstly, just marvelous engineering. This is gorgeous in there. But that flows down into there, and I believe, trying to work out which of these oil level indicators that fills. This is a little tricky. I have a sneaking suspicion that it's this hole that fills this, so they're probably unrelated. And that would make sense looking from the other side here, yeah. Oil level currently looks like it's about at this finger, which would match up with this oil level being the one this is indicated for. Question I now have, where does this oil get filled up from? Where is this indicator from? Now, the reason this is my line of pursuit in this investigation is I have a suspicion that it might have been me overflowing it that's causing the leak, i.e. maybe I put way too much oil in, I was reading the wrong indicator, and then spills over the top and then ends up dripping somewhere it shouldn't drip. Maybe it's as simple as that. I'd love it to be as simple as that. And I think tackling the simplest thing first and hopefully either working out if that is the problem or if it's not is going to be the best course of action for fixing this, hopefully. Okay, my theories are developing. Theory number one, inside of this oil tank that is fed by the top, there is a hole, and it feeds this copper oil line, which comes all the way down to here, comes underneath this this body of the lathe here, and I have a feeling that that comes up to fill the tank that is indicated off of this reservoir. And I have a feeling that it could be that line that is maybe burst and is dribbling the oil. Now, this means I now have options. This clearly is the pipe from which to drain this tank. Do I want to drain this tank? Or do I want to try and drain this main tank up here? I have no idea. I couldn't tell you what the best solution is. All I can tell you is I've got a big puddle of oil on the floor. It's only getting worse. This doesn't bode well for safely actually being able to use the lathe. And so I'm gonna just have to pick something. I'm gonna drain the top one. If my suspicion is correct that the top one is feeding the bottom one, then if I remove the source of the bottom one, that could at least eliminate the problem being up here, and then we can move down lower for finding the leak. Okay, it's been a while since I drained that tank down to the level that no oil should be flowing through that line, and still making puddles. And what's interesting, sadly, is I've now spotted this drip coming off of that part. And it just happens every so often. So I don't think that's the main cause of all of this leakage. Which is disconcerting, because that means that now it's not just one leak, it's 2 leaks. I really want to see if I can get a better view in behind this. So I'm going to try and take that plate off, and hopefully not do too much damage. Oh, well that would be the problem. Oh my goodness. So I just tugged on that hose a little bit, and would you look at what just came out? The hose! The hose came out!
Where's it supposed to go?
I have no idea. Okay, it's the next morning now. I come back in and whatever I did definitely did not solve it. The leak is far worse. There is just so much oil everywhere. It is terrible. Okay, after some research, I found that there is sometimes a place to drain the oil. And so I just take an Allen key and I start poking at the paint, trying to find it. And would you look at that? I poke at this paint, oil is now dripping down, and I have a suspicion and a hope that this hole drains this area here. Because if so, it means we're not gonna go overflowing this bottom area of the lathe anymore. I feel so stupid. I feel so stupid. I've just had that aha moment, and I feel so stupid. So let's circle back a little bit. Fill up this machine with oil. We use it a little bit, a few hours later, oil spill on the ground. Great, clearly there is a leak somewhere. Next thing that we know, there was a plugged off oil drain hole. Just discovered that, right? I was able to drain that oil out. Now that oil drain hole, right there, is about the same level as all the oil was in this little pan area here at the bottom. What else do we know? There was a mystery copper hose feeding right into that pan area, handily tucked into a groove, clearly designed for the copper hose. And that copper hose runs all the way up to this main tank, to about this level, which is about level with the sight glass for this tank. And so clearly the mystery has unraveled itself. It's as simple as this. I overfilled the oil. And this machine is designed in a way that overfilled oil, which can clearly must have some sort of damaging effects to the machine, overflowing oil gets drained away. I just wasn't smart enough to think about it. Overall, this is an utterly grand success. It's also a great waste of a lot of time investigating this, but the oil leak is sorted, and I feel like an idiot. And the oil is level now. Yay. Next update piece, I was wrong about something here on the compound on the lathe. In the episode about the first chips on the lathe, I was setting this to 45 degrees so that I could get that finer adjustment in on this. I was wrong, should have set it to 30 degrees, so I'm gonna make that change. And the next thing is, some people were wondering, hey Alec, your 3-jaw chuck jaws are inside out, they need to be flipped the other way. That's exactly what I thought when I first got the lathe. I even went so far as taking the jaws out of there with the main purpose being to flip them around and put them back in the other way, but interestingly enough, this is clear as day set up to be run with these chuck jaws this way. Now, if you're unfamiliar with what a normal 3-jaw chuck looks like, it usually looks the exact opposite to this. The longest protrusion is usually right in the center and has these little chamfers on it so that it can hold small stock. So it's a little bit funky, but I don't think it's gonna give me too many issues. Anyway, I can't mess around with this lathe for this long and not do something with it, so let's make some more chips just for the fun of it and just for the cool video. In other news, last Wednesday, I took a one-day trip down to Texas, up at 6 in the morning, back at 11:50 at night. Flew from Montana to Texas to go and visit with a new sponsor of the channel, which is Paragon. Now, Paragon is a manufacturer of kilns, knife heat treating ovens, all that fun stuff, and I headed down there so they could give me a factory tour. And the reason I'm bringing this up now is I just got a call from a truck driver who is getting ready to deliver our knife heat treating ovens. So while I wait on him, let us quickly have a look at Paragon's factory. It's a pretty cool setup. Hope you enjoy. So today's little trip has taken me down to Mesquite, Texas, to Paragon Industries. These guys make knife heat treating ovens. They also make all sorts of kilns and heating supplies for many other industries, the ceramics industry, the jewelry industry, all that fun stuff. They make a whole bunch of products. They're a new sponsor of the channel, and so we're here for a little factory tour. What is also interesting, you might have heard me talk about lean manufacturing in some books that I was reading about it. These guys do lean. They've got a huge factory, and so we're gonna have a little look around and see how these kilns get built. Now, you've already seen one of their kilns in the workshop, and that was the kiln that we used to do the wax burnouts. What we're gonna look at now are 2 knife heat treating ovens that are gonna be shipped up to Montana from here in Texas. They're gonna be crating them up, but we're gonna quickly show you those so you can get an understanding of the various parts of this, so you can then see it all come together. This is the factory floor, and here we go. Have a look at these beauties. This over here is a Pro Series 24. All sorts of fun, awesome stuff about this. This is a PK9, a much smaller model. And these are all designed to be able to get up to heat really, really fast. The one that we have in the workshop now, it's made of brick. Now, these are built for the knife maker. These are designed for knife makers who need to be able to run a heat treat fast and be able to do different thermal cycles fast, and that's what these excel at. It has sinusoidal elements inside of these vacuum-formed muffles. Beautiful pieces of kit, great accompaniment to what we already have in the workshop. So the tour is with Todd, the president of Paragon Industries. Thank you so much for having me out.
Thank you, Alec.
I'm very grateful to be here, and I think we should start out with the steel, right?
Yes.
You know, these things are going to be manufactured from steel, and the first process is going to be laser cutting.
Laser cutting the steel, yes.
This is one monster laser cutting table. This is what they're cutting right now. There's a whole lot of cutting. Holy moly, that thing moves fast. So this is Marcus, and this laser, it's kind of your baby, right? You man this operation on the laser.
Yes,
how fast is that going to make it through that cut pattern?
20 SC2 Pros in 2 hours. 20 kilns.
So you can cut out 20 kilns in 2 hours. So obviously after the laser, you got all these parts. But to put a kiln together, you got to do some other stuff. So they got a metal shop that is doing all of this. And part of what's different about how you guys are building these kilns is you're doing almost everything in-house.
Everything in-house. We buy raw material, raw brick, raw metal. We cut, we form, we spot weld, we do it all here in-house.
Fantastic. So what you saw on the laser was this. This is a one of the small jewelry kilns. All this was being burnt out. Then it's assembled with spot welds. So those ovens that we're getting for the shop, it's that vacuum-formed muffle. Well, of course, a lot of these kilns have bricks in them like the one we already have in the workshop. And this is where they're doing all the processing on that. This is their brick room. So once they got the bricks stuck together, they clean them up on the sander. They're then using just CNC routers to machine in the channels for the coils.
So here in our Paragon shop, we've got 3 internal suppliers. Obviously our brick room is a supplier, our metal shop is a supplier, and we have an electrical shop that is a supplier. From these 3 shops, we kit everything into one big kit, and it goes to the assembly lines, the appropriate assembly lines, where they then build the kilns.
So this is electric. They're just building out the components for this. And then all 3 of those suppliers.
The electrical, the brick, and the metal, they all converge and kit in front of the appropriate line.
So this central area then is where all 3 suppliers in the process, the steel, the bricks, and the electric that we just saw all comes together, and then they're able to assemble it all. We just completely missed something, which is the elements. The way these work, they're electric. You put electric current through a wire.
Right.
The wire heats up, that heats up the kiln, makes you have a very even heat, right?
Correct.
We completely forgot, and I just got shocked, you make the elements in-house.
Yes, we buy the raw material, the wire in multiple gauges, and we design and make all of our own elements.
That is super cool. So it all starts out as rolls like this. So you take the wire, It then gets coiled around these mandrels in this machine, and there's one getting coiled in that. Those elements then get pushed into these grooves here back at the assembly stage. They use these little pins pushed into that soft fabric to hold it, and that's where that CNC routing comes in, because that's where these sit. So then you guys end up with a whole bunch of kilns that need painting, right? So this is a knife making oven.
This is our popular double barrel 24, KM24. It's all assembled. The only thing that needs to be put on is the controls.
Just need some paint. And then after painting, they look nice and pretty like this. I find it super fascinating to see all of these different workstations, how it all comes together to produce these parts, and it's very cool to see a lean factory. I'll be seeing this thing back in Montana pretty soon.
Yes, that's correct.
As well as that little beauty. And just in time, because we've got to start heat treating some knives the right way. We've been doing it the wrong way for a long time, so this is going to be very exciting. Todd, thank you so much.
You're welcome.
I really appreciate the tour. Thank you for bringing all of these guys into the factory and showing us how all of this stuff gets made. Thank you very much. I appreciate that.
Thank you for taking your day and coming and visiting us. It's wonderful.
Just saw the truck pull up. There we go, that must be it.
Oh, ho, ho.
Oh, yes.
Oh my goodness.
Doesn't that look slick? That thing is beautiful. Look at that.
Oh my gosh.
This has 3 zones in it, and it controls the temperature in all 3 zones to make it as even as possible through the whole thing. So like if you open the door, the front zone cools down, and so the thermocouple in the front zone then goes, hey, more power to the front zone to bump the temperature back up and get it as even as possible. Like these things are all about the crazy, crazy accuracy increases.
Amazing.
We've got this little beauty here, unboxed and looking fantastic. That packing took some work to get through the way these are crated up, but I'm very happy with how well crated up this stuff was, because we've had some bad experiences with poorly crated equipment in the past. So, what I now need to do is I need to find a spot for these ovens. This is the table that we're currently using for this wax burnout oven, and I can just about fit that wax burnout oven and the KM24 Pro on this table side by side, but that vise is in the way, so I'm going to spin this around, give these kilns a little swivel, and then we're going to have to find a spot for the small one. Okay, we have the 24-inch Pro Paragon kiln heating up for its first ever heat up. We're gonna go to what, 1500 degrees?
Yep, that's about the temperature that you usually take a knife up to before you quench it. That big kiln took probably about an hour to get up to that temperature because it's made to handle much larger stuff. But this is made to heat up, you know, knife blades and thin stuff like that, and so it's designed to get up to temperature really quickly and then to come down from temperature very quickly. It's already up to a 95 degree. What?
That's like a minute of talking.
That's
and so
unbelievable.
Part of the design of this is it's designed with that extremely insulative material, so it gets up to temperature, but it also means that it can be extremely accurate because it's not trying to heat up this huge thermal mass. And so it can come up to temperature without overshooting and also drop down to temperatures while being much more accurate at the same time.
It is just racing up there right now. That's incredible.
Hey, we should have got some cookie dough mix. Dang. Shout out to those of you that spotted us making cookies that one time. That was, you guys have sharp eyes.
This is just a little Crew Forge V knife that I forged out a long time ago and never heat treated it. So we'll throw it in here and give it a little test. And
what is Crew Forge V?
Crew Forge V is a high carbon, high vanadium knife steel specifically designed for knife makers who forge their knives. So it's my favorite steel. It's really terrible to work with though, but it holds an edge like nobody's business.
Let's put it in. There we go. Now that it's almost at 1500 degrees, you can see the individual segments are using less and less power so it doesn't overshoot the 1500.
We just heard the alarm that we set letting us know that it's at 1450 degrees.
And that's 14 minutes.
Oh my gosh.
This means that in 30 minutes, you can have a blade ready to go into the oil. From turning on the machine, programming it.
Faster than 30
You
minutes.
reckon?
Okie dokie, y'all. We've got ourselves a knife that is right there at 1500 degrees. It's been sitting there for about 5 minutes or so, and we're gonna go ahead and take it out. And
Oh my
it.
goodness, that is beautiful in there. That is a quenched blade.
Easy. It is the most beautiful quenched blade I've ever seen.
Look at all that martensite.
It's crazy. You can see where the oxygen got to it before it was quenched because it started to scale up a little bit. But the rest of it, since that thing is sealed off from the oxygen, it hardly scaled at all.
That's a really, I did not suspect that would happen.
That's
and
really incredible.
I think part of it is it was up to heat so fast.
Yeah. Man, even with a 5-minute hold though.
That's super cool.
That's incredible. Let's wipe this thing off and have a look at it. I just wiped it off and it's like...
No. There's almost zero scale on that blade.
At all. Let's test it, because that doesn't really look like it did a whole lot because it's so clean, but... Like
There's no
glass.
bite. That is just skating right off of there. That is a hard blade.
That's incredible.
And a clean blade.
Oh my god.
That's mind-blowing. We have the kiln coming down. We're gonna get it to 400 Fahrenheit where it's gonna do a hold for a temper cycle. And this is segment 2. So we have a 9999 rate, 400 temperature for a 2-hour hold. This is a phenomenal piece of equipment and we're only 1 heat treat in. I think that we're gonna be pretty happy with this stuff. So be sure, guys, if you're in the market for a heat treating oven and you want to up your knife making game, you want to be able to increase your accuracy, increase your efficiency, make more money, and make a better product, make sure that you head on over. There's a link in the description. You go to Paragon Web. You can learn more about their kilns. You can get in contact with them. You can find a distributor near you to get yourself one phenomenal piece of equipment. It's been a pleasure bringing you along with this journey, starting out with a Leaky lathe, which I feel embarrassed about and super stupid. Going all the way to Texas in one video and back, as well as unboxing these new pieces of equipment. We've got our electrician scheduled in to come and get us some new receptacles so we can get all of those kilns wired up and get them a little further away from the wall. It has been a pleasure bringing you along. Thank you, Paragon, for being a new sponsor of the show. Make sure to check them out. It's been a pleasure as always bringing you along. See you on the next one. Bye-bye.